Hey class, this is Mr. Roberts, Shasta High School. This is problem 9 on one of Math 1's assignments. I just want to illustrate a couple things that you should always be thinking about when you're presented with a problem like this. One of the things that I'd like to see you do is very clearly identify what your variables are and what they represent, the quantities they represent. We had a lot of practice with this earlier in the year with just one equation and one variable. And we're going to look at this situation where there's multiple variables, multiple equations. So Brianna's family spent $134 on 2 adult tickets and 3 youth tickets at an amusement park. So we can see that we're talking about 2 different kinds of tickets. We've got the adult tickets and youth tickets going on there. So these are probably pretty good values to consider when setting up your variables, maybe A and Y. Max's family spent $146 on 3 adult tickets and 2 youth tickets. What is the price of a youth ticket? So we're asking what one of those variables is. What's Y? So let's go ahead and set up the equations, define our variables. So I'm going to say that A is the cost of 1 adult ticket. And I'm also going to say that Y is the cost of 1 youth ticket. So now that these variables are defined clearly, let's write an equation that expresses the relationships that we're seeing here. So if I was to write 2 times A, that is the cost of 2 adult tickets, right? It's 2 of those adult tickets. 2 times the cost of 1 adult ticket. And if I was to write 3Y, right, 3Y, that's 3 times the cost of 1 youth ticket, or the cost of 3 of the youth tickets, right, 3 of them. And if I combine these two, right, that's the sum of 2 adult tickets, the cost of 2 adult tickets, and 3 youth tickets. Now we're told that for Brianna's family, that cost them $134. The next equation we have is that 3 adult tickets and 2 youth tickets are what are purchased. So we've got 3 of the adult tickets and 2 of the youth tickets are purchased. And that costs a total of $146. Now, they're asking me to find the value of the youth ticket, right? What is the cost of a youth ticket? And, all things being equal, it looks like I could solve for either variable directly first. I'm going to choose to eliminate A. So remember, the technique we've been talking about in class is elimination or linear combinations. And looking at this equation, I could either eliminate A or I could eliminate the variables Y. I'm going to eliminate A. And to do that, I'm going to multiply both equations in this system by a certain value so that the coefficients become opposites. So I'm going to go ahead and multiply the top equation by I'm going to multiply it by 3, and I'm going to multiply the bottom equation by the number -2. And again, my motivation for those 2 values is I'm attempting to make my A variables eliminate. I want them to cancel when I add up, when I combine these 2 equations into one. And by multiplying the top one by 3, the coefficient for A will become 6. And by multiplying the bottom one by -2, the coefficient for the bottom equation will become -6. And since they're opposites, they'll easily cancel out. So I'm going to go ahead and rewrite each of these equations. Each equation has 2 terms on one side and 1 term on the right-hand side. It's very important when you're multiplying a side of an equation by a value that you multiply all of the terms on that side by the value. So I'm very carefully rewriting this equation. This is going to become 6A plus 9Ys and that will equal 3 times 134. And I just checked with the computational aid. 3 times 134 is 402. And let's go and do the same thing for the second equation. When I multiply 3a times negative 2, I get negative 6a. And negative 2 times times 2y is negative 4y. I'm just going to go and write that as a minus 4y. And then I've got negative 2 times 146. That is going to be 280, 252. No, it's not. It's going to be 4 less than 300. If that was 150, 2 times 150 would be 300. And I need to take away 4, and I need to take away 8. So that should be negative 292. And as I combine these two equations, right, I'm going to combine the a's. Again, my motivation here, and I don't want you to think this is magic or anything. This next step, if you have equal things, right, and you add to each side of that equal things, right, you will get things that are equal. So what I'm literally doing is I've got two sides of this equation, right? I've got a left and a right hand side. And for each individual equation, the equation says that the left and the right hand side are equal. So I'm looking at this quantity and this quantity are equal. And the same thing is true with the equation above that. So what I'm doing is I'm taking the equal quantities in the top equation and I'm adding equal quantities to both sides of that in the bottom equation. And the result is going to be, equal quantities. So I'm taking equal things and I'm adding equal things, so I'll get equal things. On the left-hand side, that expresses itself as, 6a minus 6a is 0a, and 9y minus 4y is a positive 5y. Over on the right-hand side, I've got 402, and I'm subtracting from that 192, or I'm adding negative 192, and I get a positive 110. So next I'm just going to go ahead and take the 110, divide both sides rather by 5, and when I do that, I get that y equals 22. So what I have here is the cost of a youth ticket, and that's all the question's asking for, so I can go ahead and report that answer, right? The cost of one youth ticket is $22. That's it.